Hey folks, today's topic is solve systems with three variables. So just a reminder, you can do this on your calc as a check at the end, but I'm going to want you to be able to do this by hand as well as being able to check it on your calculator. So there's two styles of systems with three variables. The first one is this setup here, where they gave us one equation with all three variables, then they go to one equation with only two variables, and then they finally give us one equation with one variable. This is the system that we like the best, because what we can do now is we can do something called back substitution. This is called back substitution. So that means that when you have, I don't know why I capitalized that, but they told us one of our answers. So we can take that one answer and then we can back substitute it into the equation before. So our equation before would look like y plus 4 times, well, we said in the equation, or they gave us, in the equation, the third equation, that z was equal to 2. So I can take out the z and I can sub in 2. And now I have what? One equation with one variable, which means I can solve this. 4 times 2 is 8. Who's keeping y from being by himself is 8. Subtract it over. I get y equals -1. So now we've figured out that z is 2. They gave it to us. We used algebra to figure out that y was -1. Now we're going to take those both, and we can back substitute them both into the original equation, the top equation, and figure out what x is. So we don't know x. Minus 2 times, we just figured out that y was -1 using algebra. Plus 3 times, they gave us that z was 2. And that equals 9. How many equations do we have? 1. How many variables? 1. That means we can solve it. So this is going to be x minus 2 minus 1 is plus 2. 3 times 2 is 6 equals 9. That's 8 subtracted across. I get x equals 1. So now I'm going to take all of those pieces of information and put them together to get a solution of I get an overall solution. Remember, you always go in alphabetical order. It doesn't matter what order you solved. X, and then Y, and then Z. I would encourage you to pause here and see if you can solve the next one on your own. Let's see how you did. They told me that Z was 3. I can plug that into the second line. So Y plus 3 times, we know that Z is 3, equals 6. 3 times 3 is 9. Subtract, we get y equals -3. Then we can take both of those and back substitute into the first equation. So that would be 2x. Subtract, we figured out that y was -3. For now, I'll just leave it as -3. I know it's going to change, but plus 5 times, oh no, I'm going to run out of room. 5 times 3 equals 22. So we get 2x minus a negative is a positive. 5 times 3 is 15 equals 22. That's 18. Subtract that across. That's 4 then. Divide both sides by 2. We get x equals 2. So let's take all those and put them together into a solution. X is 2. y is negative 3, z is 3. So back substitution, pretty straightforward. Next up, what happens when we don't have it set up where one of the x's or y's or z's is already solved for us? Well, we're going to take these equations, we're going to eliminate just like we did with two variables. So when we had two equations and two variables, we could take two equations and eliminate one of them. Well, we have three equations with three variables. So we're going to have to take two, we're going to have to first just eliminate one variable, but it's going to still leave behind two equations. And I'll show you what I'm talking about. So let's start off here. Let's figure out, first of all, which would be a good variable to get rid of. I could say maybe z is okay because it's easy to turn a 1 into a 3 and a 1 into a 5. I would not mess with the y's. 2, 3, and 5 are not nice numbers to turn into each other. But definitely x is the easiest one here because I have the first two lines, x's are already set up to cancel, and then I can easily set these two, I can multiply to make those two cancel. So let's take this and let's take this. Now, do I need to change them to get rid of my x's? No. So I'm going to leave them the same. X subtract 2y plus 3z equals 9. And then negative x plus 3y plus z equals negative 2. I can add these two equations together. That's 0. That's 1y. That's 4 z's. And that's 7. How many equations do we have? 1. How many variables do we have? 2. That's a problem. So we have to do a little bit more work. We have to now come up with another equation that only has two variables, but it can't just be any two variables. It has to be the variables y and z again. I don't want to now eliminate, if I eliminate x the first time, I don't want to then eliminate y the next time. I have to get y and z. I have to get two equations with only y and z. So let's use, I use line 1 and line 2. So I can use line 1 and line 3 or line 2 and line 3, but I have to use line 3 this time because I didn't use it last time. Let's do 2 and 3 because these are already opposites of each other. So I'm going to take this line, I'm going to multiply it by 2, so that would make them opposites. So 2 times negative x is negative 2x. 2 times 3y is 6y. 2 times z is 2z. And then don't forget you've got to multiply the constant as well. Easy mistake to make. It's going to be frustrating when you make it though. This, I'm happy with the 2x as is, so I'm going to leave this line the same. Negative 2x plus 2x, that's 0. 6y subtract 5y is y. 2z plus 5z is 7z. And 17 take away 4 is 13. All right, now look at in green and the sort of orange. We have two equations with two variables, which means we can now eliminate one of them. So I'm going to take line 1. Sorry, I'm going to take this equation. I'm going to take this equation and I'm going to put them together trying to kill off one of the variables. So as we look at them, before we write, let's try to be a little bit thoughtful. Would you rather get rid of the y's or would you rather get rid of the z's? You could do either, but clearly to me, the y's is a smarter choice because they're the same coefficient. I need one of them to be opposite. So I'm going to times this line by negative 1. So that would be negative y, subtract 4z, equals negative 7. I times everything by a negative 1. This line we left the same. And this is where I hope and I pray that I get a nice answer. Cancels. Negative 7 plus negative 4 plus 7 is 3z. 13 take away, yes, is 6. Divide both sides by 3, and we get z equals 2. Phew. Now, that doesn't mean it's automatically right, but it's probably right. So I'm going to now take this, and I have to back substitute it like we did before. And you can back substitute it anywhere you want. But I wouldn't put it back here because if I put 2 in for z, that's great. Z's gone, but I still have x and y. So I'm going to try to find an equation that only has a z and one other variable. So if you look, green would work or this orange would work. I'm going to use green because it's near the bottom. So I'm going to back substitute y plus 7 times, well, we just figured out that z was 2 equals 13. Y plus 14 equals 13. Y equals -1. Now I have a z, I have a y, and then I can back substitute into one of these. It doesn't matter which one. So I'll pick, I guess, the first one has the least number of negatives. I guess that's a good choice. There isn't one that jumps out to me as being really good. So let's see. So I'm going to use the first equation. I'm going to plug and chug these values. So that's going to be x, subtract 2 times, we said y was -1, plus 3, we solved that z was 2, equals 9. So that's x, -2 times -1 is +2, 3 times 2 is 6. That's 8. That means x equals 1. So now let's put all these together. And we have a solution that says, what could I use here? About this red. X is 1, y is -1, and z is 2. Okay, so I'm not going to use more class time to go over another example when you can dive into the homework and put yourself to the test. The only thing I want to point out is this step here. I kind of picked one that was really easy to cancel. You might have ones where, let's say this is 2y plus 4z and this is 3y minus 5z. You might have to do a little bit more work than I did when it came to canceling some stuff out. Same thing here. You might have to multiply a little bit more. Like I had the x's cancel out right away. You might have a little bit more work to do on yours on the homework set, but you can do it. Good luck.